7. And the kinetic investigation of the following reaction. I'm just going to start the reaction here. A2 gas plus, what's the other thing?
B2 gas.
B2 gas. Yes.
2AB gas.
2AB. It's a gas phase reaction. The following data is obtained in experiment 1 number, and then I have the concentration of A2 and the concentration of B2, and then the rate. And that's in moles per liter per second. Okay, so I've got all the units. What is the molarity here in experiment 1?
1.1 number
0.1?
for both of them.
0.1, what's my rate?
2.5 times 10 to the 4.
Okay, what's this one?
0.2.
And
0.1.
what?
0. Sorry. 1 times 10 to the -3.
And this one would be 0. What?
2.
And this is 0.2.
Yes.
And what is it?
2 times 10 to the -3.
And you can almost write this rate law from inspection, but I'm going to require that you prove it. What's it look like to you? What is this with respect to that?
1 over 0.25.
How many times this do I get this?
5.
So 2.5 times 10 to the -4 times 4 is equal to 1. See? And look at this. 1 times what is equal to 2? 2. Okay? So that would suggest, and what was it I varied? So I'm just going to look at it in a qualitative sense right up front. Do that so you don't lose track of what it is we're talking about, your in experimental instincts. And I held the concentration of B fixed, and I doubled the concentration of A, and the rate happened 4 times faster. What does that suggest about A? What order is it with respect to A?
Second.
Second order. 2 squared is 4. Okay? Now, when I held this concentration fixed and doubled the concentration of B,
It doubled.
the rate doubled. So if I double the concentration, it doubles the rate. What order does that commensurate with?
First.
First order. So I'd say that it's first order in B and second order in A. So we can almost write the rate law directly. But if you do that on the test, I'm going to throw big, large rocks at you. I'm going to expect you to prove it, but I want you to be able to think about it in those terms before you start to do it. Okay? Now let's prove it. Okay? And so what we're going to do is rate 2 over rate 1 is equal to K times 2 times A 2 to the X times B 2 to the Y divided by K times A2 to the X times B2 to the Y. And that is equal to, notice that everything here drops out. K divided by K drops out, B2 to the Y drops out, A2 to the X drops out, and that's equal to 2 to the X. And that is equal to 1.0 times 10 to the -3 divided by 2.5 times 10 to the -4, and that's equal to 4. Therefore, X is equal to 2.
Is the superscript in front of the A2, is that coming from the 0.2 molarity?
What do you mean, what superscript? Oh,
That two
this
there.
2? This 2 is exactly because I doubled the molarity. I kept this fixed, and I doubled the molarity of A. And since that's all included in the parentheses, I'm re-expressing the concentration in the second experiment as the concentration in the first experiment times 2. And that means everything drops out of this, because that cancels, this cancels, that cancels, and I'm left with 2px. So we actually set the experiments up deliberately for this to occur, to make it as simple as possible. And then I can take the two rates, I divide the two rates, and I'm equal to 4, which is basically in principle what we did without even looking at any of this when we looked at the rates. Well, what's this? What's the relation between this and this? Well, this is 4 times that. And this one is 2 times that. So we already knew it was going to be second order. But now we can show that it is. So we've proven that it's second order in A2, which is what I'm going to ask you to do on the test. And so rate 3, I got to have the E on that, over rate 2 is equal, again, we write out the same expression. At this point, I can take the information here and include it and put the 2 in front of the B2 to the Y over K Is there a mistake in the key?
Oh, you heard me? No, yeah, I was reading it ahead.
Oh, okay.
I'm sorry.
Okay, well, no, yeah, please point it out when
Well,
I get there.
it's on part B, but I'll tell you when we get there.
We'll get there when we get there.
Yeah.
Okay. So now you'll see how this one's obvious now, because in particular, this is going to drop out, this is going to drop out, and that's going to be equal to 2 to the y, and it's equal to 2.0 times 10 to the minus third divided by 1.0 times 10 to the minus third, and that's equal to what?
2.
Pretty much, yes, 2. And therefore, y is equal to 1, and at last, we can write the rate law, which was what this question was about. The rate is equal to some sort of a constant times the concentration of A squared at second order in A and first order in B. What's the overall order?
Third.
Third order overall. So that answers part A to this problem. I'm going to roll this one up. Is that good for everybody?
Yeah.
I'm going to roll this up, and we'll do part B in just eine Sekunde. Ja. And now, for part B, what is so this is pretty straight up. We've already written the rate law, and so I'm just going to rearrange that expression. K has to be equal to the rate divided by the concentration of A2 squared times the concentration of B2, the first power. And so you've already got half the problem just by writing that out. And now we just simply plug in the numbers. And at this point, if you do not include units, you're really going to lose a lot of the problem. So you definitely want to include the units. And the rate, I'm going to pick any one of those above will work. But I'm going to pick the first one for the following reason. It has a lot of ones in it. And I like 1. It's easy to multiply by. What was the...
Well, that's what the mistake was. When you picked the rate, you kind of
Use
made up a
5.
new one.
Oh, okay.
You put 5 instead of 2.2.
Okay, that was, okay.
Yeah.
That was a typo. Okay. But now I'm going to do it the way it...
Yeah.
I would have picked 1, and so I'll take the rate that's in 1, and I'm going to include the units. 2.5 times 10 to the minus 4th, and that'd be moles per liter per second. And now I'm going to divide that by, and the nice thing about these being the same concentration, this would be 10 to the minus 1 moles per liter squared, and then times 10 to the minus 1 moles per liter. Okay? And so if you include all the units, you're going to be fine. And now, wait, let's just do the math. We'll leave the top alone for now. 10 to the minus 1 squared is what? 10 to the minus 2. 10 to the minus 2 times 10 to the minus 1 is 10 to the minus 3. So I'm going to end up with ultimately something that's going to be 2.5 times 10 to the minus 4 over 10 to the minus 3 in a minute. But now let's get the units straight. This is moles per liter. That's squared, so it's moles squared per liter squared times moles per liter. So it's moles. So that's moles per liter per second, and this would be moles cubed per liter cubed. And so now I'm going to end up with, now the only math I have to do, the 2.5 is fine, and Antissa is just the characteristic I got to work in. It's easier to work in the characteristic. 10 to the minus 4th divided by 10 to the minus 3rd is 10 to the minus what? 1. Equals 2.5 times 10 to the minus 1. But now, moles per liter divided by moles cubed per liter cubed is going to be moles minus 2 to liters minus 2. So it's going to be reciprocal. It's going to be liters. It's going to be liters squared per mole 2 per second. Okay? And that is the way it should go. And now the units do work out. And I just like to put the liters in front per mole. It's just reciprocal molarity. The reciprocal molarity squared. But this is characteristic of all third order processes have these units for the rate constant. For a rate constant. For any, all the units are going to be the same for all third order processes. The rate constant is going to have the units of liter squared per mole squared per second. Okay? Are there any questions about that? And did that fix the typo? Where was the typo? I just snuck a 5 in there out of nowhere.
Well, yeah, you just used a different rate, but...
And the rate wasn't even one of the ones available. Okay, that doesn't surprise me. I make mistakes like that. Okay, does that answer that question? Okay.